we need to do for section 2 and apply the theory is we need to explain 3 examples of quadratic functions and explain the transformations compared to the quadratic parent function. To make this in GeoGebra, we start by putting in the parent function, which is always y equals x squared. And then we can add the function that we're going to show. This function is going to be y equals minus 1 over 2, 1 over 2, bracket x minus 7, close bracket squared, minus 4. Oops. Squared minus 4. And we get this function. Just start pressing the divide sign, and it creates it. So then we need to fix our graph so we can see it a little bit. We can see all the different bits and pieces. Let me show you how to label the graph. So this graph is labeled as f. What we'll do is we'll go to the settings and we'll change to show the value, and we can see it's y equals x squared now. We'll do the same for this one, and we'll show the value here for that one, and we get this. Now what's interesting when we're making these transformations in vertex form is how the vertex moves. So the vertex goes from 0, 0 to h, k. We can show the vertex in GeoGebra if we select here the tools for points. We choose extreme point, and then we select each of the graphs, and it will plot the extreme point. We can then select the move tool again, which allows us to select things. We do the settings for those two and change from name to caption. We do the same for B, change from name to caption. It'll show the coordinates of the vertex. Sorry, we want values, caption. Value. So now we can see that this one's going to be at 0, 0, and this one's at 7, 4. So then, what we need to do is we need to explain the transformations. We have the 4 questions here. What is the absolute value? What is it positive? And so on. So we have the 4 values here. What is the absolute value of A? The absolute value of A, in this case, is going to be a half. The absolute value is a half. What does that mean? It means we have a vertical compress. The vertical compress by factor 2. Because A is equal to a half. The factor of the compress, if it's a stretch, then the factor is whatever A is. If it's a compress, then it's the reciprocal of whatever A is. We turn the fraction upside down. So secondly, is it positive or negative? A is negative, that means we have a reflection, that means we have a maximum point, not a minimum point. What is the value of H? H in this one is 7. The coordinates of the vertex 7, minus 4. H is 7. That means we have a horizontal translation right by 7 units. Last question. What is the value of K? K is equal to minus 4. You can see the coordinates of the vertex. The y coordinate is minus 4. That means K is minus 4. That means we have a vertical translation down 4 units. And then this is what we need to do. So writing in Word using the equation editor, you write those 4 sentences that I've just described, and you will describe the transformations. Include a graph of the parent function and the new function, so you see the translations, and then explain. You can either explain them in words using the equation editor, or you can do a more graphical explanation. And I've shown an example here that I made earlier. You can find on the Google Classroom, where I'm explaining it not just in words, but also a bit more visually. So we've got the first one, which is that the absolute value of A is a half. So we have a vertical compression factor 2 here. The absolute, the A is negative. So we have a reflection in the x-axis, giving us a maximum point. The value of H is 7. So we have a horizontal translation right, 7 units. The value of K is minus 4, so we have a vertical translation down by 4 units. So this is how we should complete section 2.